Hello everyone! In this video, we're going to talk about the spell and effect system I built for my game. For a long time, I tried managing spells through scripts inheritance or instance scenes, but it always turned into spaghetti code, hard to maintain and even harder to scale. Let me give you an example. I have a missile script, a flying object that travels to a target and deals damage on it. Simple enough. But maybe tomorrow I want a missile that also has an area of 3D that damage characters when they walk into it. What do I do? Two separate missile scripts? One script that checks whether a zone is attached? Or one giant script with every possible behavior inside? This is honestly one of my biggest design questions. Should I allow infinite flexibility or should I set clear rules? So I ask myself, how do actual studios handle this? The answer is that spells, characters, and events are all just data, plain text files in JSON or Lua. No Firebird script in their codebase, just a configuration file. And in Godot, we have a native tool that's perfect for this, resources. I won't go into detail about what resources are, there are great videos on that topic on YouTube. Here's how everything fits together. A character has a node, or a component, called a CastManager. His job, cast a spell when we ask him. Now let's look at what a spell actually looks like. Spells are resources called SpellData. Each one is made of two parts. Metadata, name, description, icon, and maybe what do you need to cast the spell, like do you have enough mana, or maybe do you have the right object, or are you from this class? For example, this spell can only be cast by a mage or a paladin. And the second part is a list of effects to apply. When the cast manager determines that a spell can be cast, it applies all the effects. It also builds the gameContext, an object that centralizes all the information needed to execute effects, like who casts the spell and who is the target. Some components can add extra data to the gameContext if needed. Everything inside will be available to the effects in the execution list. Inside the spell data, effects aren't listed on their own. Each effect is paired with the target resolver, forming what I call an execution entry, a pair of what to do and on who. I drew inspiration from World of Warcraft spell system, where every effect is always associated with a target. The target resolver answers one question: who should this effect be applied to? The simplest one takes a key, instigator, target, or trigger, and fetch the corresponding value from the game context at execution time. But I also have more advanced target resolver, like one that fetches all entities within a radius around a given source. And actually it's very cool to manipulate because you can really make complex behavior just by changing some few variables, like who is the target or who they are. Here's the base class for my effects. It's intentionally simple. The damage effect, for instance, holds a base value and a variance. At runtime, it fetches the health component from the target, if it has one, and applies the damage. It's in the Godot style duck typing. Does this object have a health? No, then we do nothing. During development, I ran into a problem. How do you handle effects triggered by a dynamically created object, like a missile or a projectile? In my first versions, the missile was created, launched towards the target, and nobody was listened to his signals. I didn't feel it was the cast manager's responsibility to handle that, so the question remained: who should? I had built an intermediate layer, a spell instance, to link spawn objects back to their effects. But it was heavy, hard to debug, and left nodes floating around with no clear ownership. The solution: if an effect should trigger when a projectile hits something, that logic needs to live inside the projectile itself. Now it's time to show you some spells, some real example. Okay, let's take the Blizzard spell. The entity is made of 5 components: a collision one, a timer one, a visual component, an effect map component, and a feedback component. The last two are at the heart of the system. They each hold a map that links an event to a list of effects. The collision component exposes on-body entered and on-body exit. The timer component exposes on tick and on duration. These identifiers aren't hard-coded. They are defined in the editor, and a small tool I built scans them in real time and surfaces them as selectable options in the interface. When an event fires, the effect map component catches it and applies all the effects registered under that key. For Blizzard spell, damage triggers on tick, and the zone disappears on duration. Now let's look at something more complex: the Shaman's Chain Lighting from Vanilla WoW. On the spell data side, it's simple. A single spawn entity effect that instantiates the chain lighting entity. All the spell's intelligence live inside that entity through a chain component that handles bounces and the detection radius between each jump. The effect map component then distinguishes between two events. On the first bounce, high damage then trigger a new jump. On subsequent bounces, reduce damage, but the chain continues. When the chain reaches its maximum number of bounces, or runs out of targets in range, the entity destroys itself after a short delay. Okay, let's try to make a missile that also has an area 3D that damages characters when they walk into it. I will try to show you almost in real time the full process. Well, that's all for this devlog. Let me know what you think in the comments, and see you in the next video. Bye!